So in this video, we are going to discuss the exercise questions that we have in class on permutation and combinations. The questions, you can find it on the lower right corner. So we begin with the first one. So we are interested in the number of permutations of the letters A to H if the three letters A, B, C has to occur consecutively. So which means that A, B, and C must occur together and in order A, B, and C. Now, if you don't care about this at all, and we just care about the permutations of the letters A to H, so in that case, there are going to be 8 factorial. So why 8 factorial? Because there are 8 letters, A, B, C, D, E, F, G, H, and there are 8 factorial ways to order them. Now, but in that particular case, where we have 8 factorial possibilities, many of them is going to contain the cases when A, B, and C may not appear together nor consecutively. So for them to be guaranteed to appear together and consecutively, we are going to group them together. So we are going to create essentially a new letter, which is in this case is ABC, and we're going to box it up, and we're going to say that this is equals to a new letter X. Then essentially, we only have 6 letters to deal with, because then we have the letter X, the letter D, the letter E, F, G, and H. 1, 2, 3, 4, 5, 6. There are only 6. So now we can then try to permute these 6 numbers, in which case there are 6 factorial ways of doing this. Okay, so when we do this, then X is going to take on different possible locations. So X can be in the first place or second or third and fourth and fifth or sixth. And wherever X is, we're just going to substitute that for A, B, and C. So the answer to the first part is 6 factorial. Now, what if they must appear together, but not necessarily consecutively? What it means is that they must appear as a group, but they may appear in different order. So for example, it could be ABC, or they could appear in ACB. Now in this case, this is going to be a different possibility. Now, one way to think about this is that in 6 factorial, we would have generated all the possible permutations, in which case there is a box X. Now within this box X, initially, there's only one possible permutation, which is A, B, and C. But in the case where within this box, the 3 objects can actually permute themselves. And within this box, there's going to be 3 factorial ways in which the 3 objects are going to order themselves. So in that sense, for every permutations that we can get here, let's say X is in the first place, there are going to be 3 factorial ways to arrange the 3 objects to occupy this X. So in that case, the total number is going to be 3 factorial times 6 factorial. Now this is the answer to the first part, to the first question here that is in the first part of the slide. Now we are going to talk about the second part, about sitting people around a dining table. Now in this case, we have a dining table. Okay, and the dining table can sit 6 people. So let's actually have the chairs drawn up. Now there are 6 chairs, and we are going to number the chairs here so that it becomes easier to see. So this is chair 1, chair 2, chair 3, chair 4, chair 5, and chair 6. And at the same time, there are 4 guests, including yourself, meaning that you're one of the 4. So let's call the guests G1, G2, G3, and G4. Now we want to sit these guests on this dining table, which means that we want to determine for every guest which chair are they going to be assigned to. Okay, now in this case, We can think of this first in terms of the product rule. For guest number 1, there are going to be 6 chairs to choose from, C1 to C6. So in that case, there's going to be 6 possibilities for G1. For G2, since G1 would have occupied a chair, G2 only has the other 5 to choose from. So in that case, is 5. And G3 is going to have 4 to choose from, and G4 is going to have 3 to choose from. So in this case, we have essentially 6P4, which is 6 times 5 times 4 times 3. And this is one way to get the answer. Now, but this is not the only way. So we can also think of this in terms of a combination of, well, combination and permutation. So just now we think in terms of assigning chairs to people. We can also think of this in terms of assigning people to chairs. So in that case, we can figure out, let's say for every chair, who is going to sit on it. But there are more chairs than there are people. And since there are 6 people, but only 4 chairs, first we are going to choose 4 out of 6 chairs. Now, once you have selected 4 out of 6 chairs, then we can figure out who is going to sit where. And since they have been selected 4 chairs, so for each selection of 4, we are going to have 4 factorial ways of arranging people around the table, meaning around to occupy the 4 chairs that have been selected. And these two numbers are essentially going to be the same. All right, so this is the answer to this second question on this slide. We are now going to look at the next slide of exercises, and we're going to discuss them as well. So we would like to form a 7-member committee consisting of 3 faculty members and 4 students. There are 40 faculty members and 300 students. So how many different ways can we form the committee? Now in this case, we are only interested to form the committee. So which means that suppose that there are 3 faculty members, so there are 3 seats for faculty members, and then there are 4 seats for students. So we can think of this in terms of how do we select 3 people to occupy these chairs. Now, there are 40 faculty members. So in that case, but there are only 3 chairs. So we need to select out of 40 which 3 faculty members are to sit on those chairs. On the other hand, for students, there are 300 students, but there are only 4 seats. So in that case, you have to choose 4 of them. Now, do we care about the ordering among the faculty members here? Now, if there is a specific information where the ordering actually matters, for example, if we say that, one person is going to be the chairperson, another one is going to be vice chair, another one is going to be secretary, in that case, it matters who is what. But here we are only looking at 3 committee members, so essentially we can assume that they are equal, that whichever chair they sit on essentially is still the same committee. So in that case, we don't actually care about their ordering. And the same way, this is true for the students as well. Now, but for every 3 faculty members that we select, we can pair them up with any of the 4 students that we select out of 300. So in that case, you need to multiply these 2 numbers, and this is going to be the answer to this question. Now, we are now going to look at the last exercise question here. And in this case, we are told that we want to find how many ways are there for 3 men and 3 women to stand in a line so that no 2 women stand next to each other. So 2 women cannot stand next to each other, which means that a woman can only stand between 2 men. Now, but there is no such requirement for men, meaning that 2 men may stand next to each other. Now, one way to think about a problem is that we can actually try to simplify this by breaking down the problem. So let's assume first that we're going to have 3 men and 3 women, right? So let's actually try to arrange the men first. So there are 3 men. Man 1, man 2, man 3. And we can create different permutations of the 3 men. And in effect, they're going to be 3 factorial ways of ordering the men. Now, we then need to figure out where the women should be. Now, because any woman must stand between any 2 men, or it could also stand besides only 1 man as long as no 2 women stand next to each other. So this creates essentially 4 different locations where a woman could be. So a woman could be here, it could be here, could be here, or could be here. So in that case, there are only 4 possible slots for the women. But since there are only 3 women, so we first need to select which 3 out of 4 we are going to use. So this gives us 4, choose 3. Now once you have selected the 3, for example, let's say if we select this one, and this one, then we need to put the women there. And again, there are going to be 3 factorial ways of putting the women on the different slots. So in that case, the final answer is going to be a multiplication of this number. And we get the total number of possibilities to arrange 3 men and 3 women so that no 2 women stand next to each other.